Okay, in this video, we're looking at functions, domain and range, and then some intervals. Okay, so first on functions, we talked a little bit about this in the past video, but do these represent functions or not, these graphs? And remember, for this, we want to use what's called the vertical line test. Okay, so we draw a vertical line, and it can only touch in one spot. So there it's good, here it's good, here it's good, but notice right here, right? And maybe I'll do a real line on this one. I'll make it nice and thin so you can see. Notice what happens in this spot right here. I'm going to take that line and shift that over just a tiny bit here, right to right there. See, it's touching in two spots, right? It's touching right here, and it's also touching right here, right? So is this a function? No, it's not a function, right? Because it fails the vertical line test. Okay, so we would say this fails vertical line test. Okay. Okay, let's look at this one here. Is this a function, right? So can we draw vertical lines? One spot, one spot. Yeah, it looks good, right? So we'd say yes, this is a function, right? It passes the vertical line test. This is not a function, right? I mean, so let's take when x is -2 and draw in a line right there, right? It touches in three spots, 1, 2, 3. So we'd say no, it's not a function. And maybe it's important just to look at what's happening here. Notice our input in this case is -2, right? So remember, input is like x, okay? And what's happening with our output? Remember, that's y, or in this case, f of x. What's happening so when x is -2, there's three possibilities, right? Do you see that? What's the first possibility? Well, we can get -2, we can get -1, or we can get 2.5, right? And it's this scenario that makes it that we can't have as functions, right? It needs to go, for like on this one, right? We have our input and output, right? So look at our input. -3 goes to 1.5, right? -1 also goes to 1.5, right? So we need to have just a 1-to-1 kind of correspondence there. Make sense? Okay. On this next topic, we're looking at tables and see if they represent functions. And so, okay, let's look at our x's. X is 2, y is 4. That's good. X is 3, y is 5. Okay. X is 3, y is 9. These two right here make it no, right? And remember, here's our input, our output. When x is 3, there's two possibilities, right? It says that you can get either 5 or 9, right? And so this makes it, no, it's not a function. Okay. On this one, x is 0, y is 7, 1, 9, 2, 7, 3, 8, 4, 10. This one's yes, right? Because everything is 1-to-1, right? We call this 1-to-1, right? I guess this would be over here. This over here would be 1-to-2. Right? You got that? Okay, next up. Now, so for ordered pairs, we're looking at the same thing. We want 1-to-1. 1-to-1 is a good thing. It gives us a function. So let's look at this. X is 1, y is 2, x is 3, y is 5, x is 3, y is 8. This part right here doesn't work, right? Because look, here's our input in our output, when x is 3, there's those two possibilities. 5, x is 3, y is 5, x is 3, y is 8. So that's a no. On this one, 1, 2, 3, 4, 5, 6, 7, 9. That one looks good, right? So this one is a function. Okay. Next one. Now this is a brand new topic here. It's domain and range. Okay. First thing about domain and range is you got to look at the arrows or just the end of these things, right? So this may be a little bit tough to see, but do you see that is a dot right there? It's a dot, and that's a point as well. Whereas these guys are arrows. What do those arrows mean about this graph? Well, that means, like, this is just a portion of it, right? That goes to infinity and negative infinity, right? It just keeps going forever. Okay, so when we talk about domain is all of the possible x values. Okay, so for domain, we're looking at x. Range, we're looking at y's. Okay, so for x values, right, and I'm going to switch to a different color here. What's possible? On this one, x goes from -4 to where? To 3. That's it. Right? So we write our domain like this. We do the squiggly mark, and then we say -4 to 3. That's the only thing that can happen on this. Okay? For our range, now here for our range, and maybe I'll use blue for this part. For our range, we're looking at the y values. Oops. For our range, we're looking at y values. So what happens? It goes from, our y values go from 1, and when I say y, I mean f of x, right? Interchangeable, to 4. Do you see that? So we say the range is 1 to 4. Squiggly mark. Okay. Over here, let's look at this one. Do you see this goes to, from, like I said, from negative infinity to positive infinity? We call this the domain, right? On this one, the domain, what's the possible x values? Well, it goes, could x be -100? Yes. Could x be +100? Yep. 1,000? Yep. So we call this all real values. Okay, sorry, there's a cat on my computer. No joke. Okay, and all reals has this crazy symbol. It's written like this. It's written as this like double R thing. Okay, and on the range, actually, sorry, I'll use blue again. It's just helpful. Okay, so on the domain, we got that. On the range, we're looking at all the possible y values. Could this go up to 100? Yep. So again, this is all reals. It just goes to infinity. All reals, and we write this with this double R. Cool. Okay, let's go on to this next one. Okay, let's look at the domain and range for this. Okay, so on the domain, what happens with these x values? Well, that's a dot, right? And this is an arrow. Do you see that? So our domain starts at 0, right? So what's possible for x? We go from here to positive infinity, right? And so we write that as, just a second, this cat is, we write that as x is 0 to positive infinity, right? That's all the possible x values. Okay, now let's look at the range. Okay, the range goes from right here, and notice it also goes to positive infinity. You can put in anything, right? So we say that's 0 to positive infinity. Cool. Okay. On this one here, let's look at the domain first. Okay, so the domain, notice these are arrows, so that means it goes forever in both directions, right? So we say the domain is all reals, okay, and our range, what's the lowest value? The lowest value is here, and then everything else is possible. Eventually it's going to go all the way up. So we say that is 0 to positive infinity. Okay? Make sense? So that's kind of basics domain range. On tables, we write the domain and range as just the I'm actually gonna just ignore that one for a second. Just take notes. Let's just look at this one. On a table, the domain and range just represent everything that you see. Okay, so the domain, right? Remember, is the x values. So we say the domain is, and we just write these points out: 0, 1, 2, 3, and 4. Right? That's what we're given. The range is 7, 9, 7, 8, and 10. See that? Okay, so that's it for tables. And then for points, we basically do the same thing, right? We're going to just for the domain, and let's just do one of these. There's no need to do two. Get rid of this guy. Right, for this guy here, so we're going to write the domain is all of the x values: 1, 3, 5, and 7. We close that out. Okay, and then the range is all the y values. So 2, 4, 6, and 9. Okay, that's it. Okay, so that's kind of the basics of domain and range. And then the last topic is increasing and decreasing and no change. And this is just like when we're looking at this, we're looking at, we're reading left, we're starting here and we're going left to right. Okay, just always keep that in mind. Okay, so it's kind of like reading in English, right? Left to right. Okay, now increasing is going to be where we have a positive slope. Okay, so, and we just want to work in x values on this. And so what we do is we, we'll do increasing, decreasing, and then no change. Okay, and we'll write out these intervals. Okay, so where is it increasing? We'll start here. It's increasing from, notice that arrow tells us that's coming from where? That's coming from negative infinity, right? You see that? So it's increasing from negative infinity to, and so just kind of follow this up. It's increasing, increasing, increasing to negative 2. So we close that out. Then what happens at negative 2? It starts decreasing, right? So it starts decreasing at negative 2. And it goes from negative 2 to positive 2. Cool. And then it starts increasing again from 2 to positive infinity, right? That's also going to keep going on. So it's increasing again from 2 to positive infinity. You got that? Okay. Let's go on to this one here. I'm going to, just for this, because we're going to be writing a bunch of stuff, erase stuff as we go. So I'm going to erase this. We'll move these guys over. Where's increasing, decreasing, no change. So for this, okay. Notice this is a dot, so it is increasing from -4 to -2. We just look at these x values, right? So we say the first interval it's increasing on is -4 to -2. Okay, but notice it's also increasing from -2 to 2, right? So really, and I made a mistake on this one, right? We say it's increasing from -4 to 2, right? So this keeps going on. You see that? Okay, now what happens here? Here we have this straight line. This is an area of no change. So there's no change from 2 to 3. Okay? And then at 3, it starts decreasing, and it decreases to positive infinity. So it decreases from 3 to positive infinity. Okay? Make sense? Okay, let's do one last one here. Maybe I'll just clear all the ink. No, okay, I'll just bear with me. Okay, so where is it increasing? Remember, left to right. So we start here at -4, and now that's going down. And it goes down all the way to -2. That's decreasing. So decreasing -4 to -2. Okay, and then it starts increasing -2 to 2. And then from 2 to positive infinity, there's no change. Okay. So that's the idea of increasing, decreasing, no change. You just look at the x values. Okay, so that's it for the video. Thanks for watching.